There's a method that costs $3 and removes rust permanently, not slows it down, not delays it, removes it completely at the molecular level, and converts the bare metal surface into a protective barrier that corrosion cannot penetrate again. 1 bucket of salt water, 1 9-volt battery, 1 steel rod from your garage, and every orange flaking surface on every tool, vehicle frame, axe head, cast iron pan, and brake component you own becomes clean bare metal within 60 minutes. The United States Navy used this exact electrochemical process to restore corroded ship components during World War II. Archaeological conservation teams at the British Museum use it today to restore 2,000-year-old iron artifacts without damaging a single millimeter of original metal. Blacksmiths across 19th century rural America used a primitive version of it to restore farm tools after every wet season. And the $400 billion auto parts industry has spent 70 years making sure the words electrochemical rust removal never appear in a single mainstream publication aimed at car owners. Not because the method is dangerous, not because it requires specialized equipment, because a 9-volt battery and a plastic bucket full of salt water is not a product you can sell at $300 per application. This is buried survival secrets. They buried the science. We dig it up. Before we go any further, if you have a rusted tool, a rusted vehicle frame, or a rusted cast iron pan sitting somewhere in your house right now, drop the word rust in the comments. We want to know how many people are dealing with this exact problem right now. And subscribe, because the suppression section of this video is going to make you genuinely angry at every rust product you have ever purchased. The auto parts aftermarket in the United States generates over $300 billion in annual revenue. Corrosion-related repairs, replacement body panels, brake lines, exhaust systems, suspension components, wheel wells, and frame sections account for roughly 30% of that total. $90 billion every single year flows through garages, dealerships, and body shops because of rust damage alone. Now hold that number in your mind while I tell you what a 9-volt battery and 3 tablespoons of salt can do to the rust on a 50-year-old truck frame in under 2 hours. The industry needs rust to be an ongoing, recurring problem. A problem you treat, retreat, treat again, and eventually replace entirely. The moment rust becomes a solved problem, it stops being a revenue stream. And a 9-volt battery that costs $1 at any grocery store checkout aisle is not a revenue stream that any publicly traded chemical coatings company can build a quarterly earnings report around. Quick note before we go deeper, electrolysis rust removal involves low voltage electrical current and water. Always work in a ventilated area and never use stainless steel as your sacrificial anode. We will explain exactly why in the instruction section. This method is safe for home use when basic precautions are followed. The history of electrolysis as a rust removal technique begins not in a garage or workshop, but in a physics laboratory in 1800, when an Italian scientist named Alessandro Volta constructed the first true electrochemical cell. Volta was not thinking about rust when he stacked alternating discs of zinc and copper separated by cloth soaked in salt water and produced the first sustained electrical current in history. He was thinking about electricity. But what he had actually created was the foundational understanding of how dissolved ions in salt water conduct electrical current between two different metals. That understanding would take another 70 years to reach practical rust removal applications. But the chemistry was already complete in 1800. By 1870, industrial electroplating facilities across Britain and Germany were using controlled electrolysis to deposit protective metal coatings onto iron and steel components at scale. The engineers running those facilities noticed something that the rust removal industry has tried to keep quiet ever since. When you reverse the polarity of an electrolysis setup and make the rusted iron object the cathode rather than the anode, something remarkable happens. The iron oxide, the orange flaking compound that we call rust, does not just dissolve, it undergoes a reduction reaction. The oxygen atoms bonded to the iron atoms in the rust compound are pulled away by the electrical current, and the iron oxide reverts toward its original metallic iron state. The rust is not removed by scrubbing or aerating. It is electrochemically converted back toward the metal it came from. The British Royal Navy formally documented this process in 1887 in maintenance records from the Portsmouth Naval Dockyard. Engineers treating corroded iron fittings on warships with reversed polarity electrolysis reported complete rust removal from heavily corroded surfaces in under 90 minutes using nothing more than salt water and a basic electrical source. Those records sat in the National Archives for over a century. The auto industry built a $400 billion market in the same period. By 1943, the United States Navy had refined the electrolysis process for field use aboard warships in the Pacific Theater. Salt spray corrosion on steel components in tropical Pacific humidity was destroying equipment faster than combat damage in some cases. Naval maintenance crews developed a portable electrolysis kit using a 12-volt car battery, a steel sacrificial rod, a canvas bucket, and ordinary sea salt. The process required no chemicals, no grinding equipment, no protective coatings, and no specialized training. A maintenance rating with 30 minutes of instruction could restore a heavily corroded rifle component, a seized bolt assembly, or a corroded electrical fitting to functional condition in less than 90 minutes. The Naval Engineering Bulletin published a summary of the Pacific Theater maintenance protocols in 1947 after declassification. It described electrolysis rust removal as the most cost-effective and material-preserving corrosion treatment evaluated during the war period. It recommended adoption as standard practice across all Navy maintenance facilities. That recommendation was quietly shelved by 1953 as DuPont, Rust-Oleum, and a coalition of chemical coatings manufacturers lobbied the Department of Defense Procurement Office to adopt synthetic petroleum-based rust inhibitors as the military standard. The chemical industry had spent the war years building manufacturing infrastructure for synthetic coatings. They were not going to lose that contract to a bucket of salt water and a car battery. The modern rust removal industry that exists today was not built because electrolysis failed. It was built in the gap between what electrolysis costs and what a corporation can charge for a branded alternative. Every can of rust converter on the hardware store shelf costs between $15 and $30. Pull the safety data sheet on any major brand. The active ingredient is either phosphoric acid or tannic acid or a combination of both. Phosphoric acid costs approximately 40 cents per liter in bulk. Tannic acid costs approximately 3 cents per gram in bulk. The chemistry inside that 15-ounce bottle costs the manufacturer less than 25 cents to produce. They are charging you a 6,000% markup on basic chemistry that your great-grandfather's blacksmith used for free from oak bark and rain barrel water. The electrolysis method requires no chemistry at all, salt water and a 9-volt battery. The salt costs less than $1 for enough to treat a full-size truck frame 3 times over. The battery costs $1 at a grocery store checkout. The total investment is under $3, and the treatment is permanent, not because of a coating sitting on the surface waiting to peel, but because the electrochemical process physically converts the iron oxide back toward metallic iron and simultaneously deposits a thin layer of magnetite, which is black iron oxide, onto the clean surface. Magnetite is the stable, non-coring form of iron oxide. It is the same compound that naturally forms on well-seasoned cast iron cookware. It is chemically inert, water-resistant, and bonds permanently to the steel surface at the molecular level. The electrolysis process does not just remove rust. It replaces the unstable corroding surface with a stable, non-corroding one. That is why the treatment is permanent. You're not applying a barrier over a problem. You are solving the problem at the level of the metal itself. Now, here is what a correctly executed electrolysis rust removal setup looks like, and exactly what materials you need. You will need a plastic bucket or container large enough to submerge the rusted object. You will need water. You will need ordinary table salt or washing soda, sodium carbonate, which works significantly better than table salt and costs approximately $2 for a box that will last you years of treatments. You will need a 9-volt battery or a 12-volt car battery for larger objects. You will need 2 lengths of copper wire for connections, and you will need a sacrificial steel anode rod. Any scrap steel will work. A steel rebar section from a hardware store costs under $1 and will serve as your sacrificial anode for dozens of treatments. That is the complete materials list. Total cost under $3 for the first treatment. Near zero cost for every treatment after that. Step 1. Prepare your electrolyte solution. Fill your plastic bucket with enough water to fully submerge the rusted object. Add 1 TBSP of washing soda per liter of water and stir until fully dissolved. If you're using table salt instead, use 2 tablespoons per liter. The washing soda solution is preferable because it produces less chlorine gas during electrolysis than salt water does. The amount produced at 9 volts is negligible in open air, but washing soda eliminates the variable entirely. Your solution should be slightly cloudy. That is correct. Step 2. Position your sacrificial anode. Place your steel rebar or scrap steel rod in the bucket so that it is submerged in the solution, but not touching the rusted object. The anode and the rusted object must not make physical contact at any point during the process. Connect the positive wire from your battery to the sacrificial steel anode. Connect the negative wire from your battery to the rusted object. This polarity is critical, and it is the most common mistake people make. Positive to the sacrificial anode, negative to the rusted object you want to clean. Reversing this polarity will electroplate rust onto your object rather than removing it. Step 3. Submerge the rusted object. Lower the rusted object into the electrolyte solution, ensuring it is fully submerged and not touching the sacrificial anode. Once both are submerged and connected, you will immediately see small bubbles forming on the surface of the rusted object. Those bubbles are hydrogen gas being released as the electrolysis reaction begins. The rust will also begin releasing into the solution, turning the water progressively darker brown as the treatment proceeds. This is correct and expected. Step 4. Wait. For light surface rust on tools and small objects, the electrolysis process requires between 30 and 60 minutes to complete. For heavy, deep rust on vehicle components, frame sections, and severely corroded parts, allow 2 to 4 hours. For objects with extreme rust buildup spanning decades, allow an overnight treatment of 8 to 12 hours. You will know the treatment is complete when the surface of the object visible through the solution appears uniformly dark gray to black rather than orange or brown. That dark gray-black surface is the magnetite layer. That is your permanent protective finish forming in real time. Step 5. Remove and rinse. Remove. Remove the object from the solution and rinse immediately with clean water. The surface will appear dark gray to black and will feel slightly rough to the touch. This is correct. You will see the magnetite layer clearly. Use a stiff brush or steel wool to lightly scrub the surface under running water. This removes any loosened rust residue and exposes the clean magnetite surface beneath. The surface you see after scrubbing is bare metal, protected by a permanent electrochemical conversion layer. Step 6. Apply your finished coat immediately. This is the step most people skip, and it is the step that determines whether your treatment lasts 1 year or permanently. The magnetite surface is clean, bare, and highly receptive to any protective finish you apply. For tools, apply a thin coat of boiled linseed oil, mineral oil, or melted beeswax rubbed on with a cloth, while the surface is still slightly warm from handling. For vehicle frames and undercarriages, apply rubberized spray, undercoating, or used motor oil. For cast iron cookware, simply reseason in a 350-degree oven as normal. The magnetite surface bonds more effectively to any top coat than bare polished steel does. Apply your finish within 30 minutes of completing the electrolysis treatment before any surface oxidation can begin. A mechanic in rural Wyoming began documenting electrolysis treatments on a 1984 ranch truck frame in 2018. The frame had 40 years of accumulated rust from mountain road salt and creek crossings. After a single 48-hour electrolysis treatment using a 12-volt car battery and a 50L plastic stock tank filled with washing soda solution, he reported complete removal of surface rust across the entire treated section. 3 consecutive Wyoming winters of heavy road salt exposure later, the treated sections showed absolutely zero rust recurrence. Zero. The untreated control sections on the same frame developed visible new surface rust within 6 months of the original treatment date. The electrochemical magnetite conversion layer performed exactly as the 1947 Naval Engineering Bulletin predicted it would permanently, not because a coating was sitting on the surface, because the surface itself had been transformed. Here's what the auto industry and the chemical coatings industry need you to believe. They need you to believe that rust is a complex, recurring problem that requires professional expertise, expensive equipment, proprietary chemistry, and ongoing retreatment every 12 to 18 months. They need you to believe that the $300 to $800 professional rust treatment service at the dealership is fundamentally different from anything you could do at home. They need you to believe that the $15 bottle of branded rust converter on the hardware store shelf represents advanced technology rather than basic chemistry that any person can replicate for under $3. And they need you to never once connect the words electrolysis, saltwater, and 9-volt battery in the context of rust removal. Because the moment that connection becomes widely understood, their entire recurring revenue model for corrosion repair collapses. The American auto parts aftermarket generated $90 billion in rust-related repair revenue last year. Every single dollar of that revenue depends on rust remaining a problem you manage rather than a problem you solve. A 9-volt battery is not a problem you can manage into a quarterly earnings report. It is a problem you can solve in your driveway this afternoon for $3. Every civilization that worked iron understood the electrochemical principle, even without the vocabulary to describe it. Roman blacksmiths who soaked iron tools in copper sulfate solutions were accidentally creating primitive electrolytic cells. Japanese swordsmiths who applied alternating acid and alkaline solutions to blade surfaces were cycling the metal through reduction and oxidation states that modern electrochemistry can now explain precisely. The knowledge existed in fragments across cultures for 2,000 years. The complete scientific framework arrived with Volta in 1800, and the practical application was documented and proven by the United States Navy by 1943. For 80 years, that documented proven solution has been available in naval archives, in academic electrochemistry literature, and in the hands of the small number of restorers, blacksmiths, and conservation professionals who never forgot it. For 80 years, the chemical coatings industry has spent billions in marketing budgets, making sure that knowledge stayed in those archives and never reached the person staring at the rust on their truck frame in a driveway in Ohio. $3, one battery, one bucket, 60 minutes. That is the distance between the rust on your tools right now and the bare, clean metal underneath it. The Navy knew it in 1943. The British Museum uses it today. The auto industry has known it the entire time. Now you know it too. That is buried survival secrets. Subscribe now and share this with one person who has been paying mechanics to manage a problem that a 9-volt battery solves permanently. Every share keeps this knowledge alive. We publish forgotten survival science every single week. The grid is still live. We will see you in the next one. This video is for educational, informational purposes only. Always perform electrolysis rust removal in a well-ventilated area as the process produces small amounts of hydrogen gas. Never use stainless steel as the sacrificial anode, as this produces toxic hexavalent chromium compounds in the solution. Always use plain carbon steel or cast iron as your sacrificial anode. Dispose of used electrolyte solution responsibly, as it contains dissolved iron compounds. The creator takes no responsibility for outcomes resulting from application of techniques shown in this